exactly what I thought, yes. So this is very special. I think it's very special. And she is from ESA. I'm going to say it right this time, hopefully. The European Space Agency. And she was on the International Space Station up in space. And she held for a while. It's been since broken. But the longest long-term space flight for a woman, it was 199 days. But now it's broken. So, but I think 199 days in space is a fairly lengthy period of time. So I'm enormously impressed. So she's going to come out here, do a wee presentation, and then you can ask any questions you've ever wanted to ask of an astronaut. So put your hands together. Please welcome on stage Samantha Christoforetti.
Thank you very much. Thank you. All right, thank you. Thank you. She really trained you well. Oh my gosh. Thank you, thank you. I was commenting today, it's so funny because all these actors are coming here and they do movies where they wear costumes, but I understand they come here and just wear normal clothes, and the only one who is not an actor is actually showing up in their sort of costume, which is kind of interesting. But anyway, I have a short presentation for you this morning. Thanks for showing up so early on a Sunday morning. I think that's really cool. I'll try to keep it as short as possible. Although I always say that, and I do tend to speak quite a little longer than I think, but I'll try to keep it brief and leave as much time as possible for you guys' questions. So my story started like that. I grew up in a tiny little village in the north of Italy. It was before climate change, so there was a lot of snow back then. And I was I don't know, I was a very strange child, I guess, because, you know, I was up there in the mountains, but I actually started dreaming when I was about that age of spaceships and flying into space. And some of those spaceships were real, like the space shuttle. It was the 80s, so of course it was the beginning of the space shuttle program. And some of them were not quite so real, but they were equally cool. And I guess that dream, that childhood dream, set me on a path of studies. You know, I went on to become an aerospace engineer. Then I decided to join the Air Force. It became possible at some point when I was about 23, 24 years old for women in my country, in Italy, to join the Air Force, become pilots. So I did that. And eventually in 2009, when I was 32 years old, I was lucky enough to be selected to join the European Astronaut Corps by the European Space Agency. And so I became an astronaut together with 5 young professionals from all over Europe, from different countries with different backgrounds. Some of us coming from aviation engineering, some of us coming from science, some of us civilians, some of us military, so a diverse group. And we started a journey of several years of training that brought us in different places in the world at the sites of the different space agencies that contribute to the International Space Station. So I spent several years with my suitcase, always packed, bouncing around the continents from Houston at NASA, of course, to Star City, this marvelous legendary place near Moscow in Russia. A little bit here nearby in Cologne. I actually live here, very close to here, because we have the European Astronaut Center, and of course that's where we did our basic training, and we also did some ISS-related training, and a little bit of training also in Japan and Canada, all partners of the International Space Station. And then, a few years later, so about 5 years after I was selected as an astronaut, my big adventure in space started. We called the mission Futura. You can see that the 100 plus 100, that makes 200, so I want to hear nothing about this 199 days. 200 days, that's my story, I'm sticking to it. Just... So this is where it started, in Kazakhstan, at the Baikonur Cosmodrome. Again, legendary place, same place where Yuri Gagarin, Valentina Tereshkova took off from or launched from in the early 60s. I'm wondering if you guys up there can do some magic and maybe lower the light just a little bit on the slide so we can see the colors a little bit better. I'm sure they can do some magic up there with the lights. There we go, so much better, thank you. Sometimes you just have to ask for things and they magically happen. Yeah, and so this is of course the beginning of the mission. You know, you're sitting at the top of this rocket, and all of a sudden the engines light up, and you are on this journey to space. Of course, I wasn't alone. I had a crew. So all my life, I had dreamt of a crew like this one. That didn't happen, but I still had a wonderful crew, a small crew of 3, an international crew. On the left, Terry Virts, NASA astronaut. In the middle, Anton Shkaplerov, a Russian cosmonaut, our commander. And by the way, all 3 military pilots, so very, very unique crew. There's usually always an engineer or a scientist, but in that case, we were all military pilots of our respected air forces. And then how about a spaceship? Wasn't this one? Would have been cool, but still, we had a tiny little spacecraft. It's called the Soyuz. Just to confuse the enemies, the Russian gave the same name to the spacecraft and the rocket. So there's a Soyuz rocket and there's a Soyuz spacecraft, which is this one, which is really small. I mean, it's smaller than this stage for sure. It's about 7 meters from the front to aft. And not all of it is habitable by humans. And especially during launch and landing, you're really only stuck in the central part of it, so about 1/3 of that volume. So, you know, you're kind of like crunched up with your knees in your chin almost for about 6 hours until you actually get to the International Space Station. Here it is. Amazing facility in low Earth orbit, about 400 kilometers. If you set it down on the ground, it would have the footprint of, roughly the footprint of a football field. Took many years to build. Obviously, we didn't launch it like that. We launched it piece by piece, kind of like Lego, and they all fit together, which is pretty cool. And it's been, as I mentioned earlier, of course, it's the product of this huge international cooperation of many space agencies, one of which, of course, the European Space Agency. This was our full crew. So when we went up there and knocked on the door, the 3 of us at the bottom, those 3 on the top actually opened the door for us, and they had a warm meal to welcome us, and they took us by the hand, especially me as the rookie. I was kind of shaky at the beginning up there in microgravity, and they really helped us out, especially the first few weeks, to get up to speed and get used to life and work on the International Space Station. As a whole, so the 6 of us, we were Expedition 42. Now, of course, you guys know that 42 is the answer to the ultimate question of life, the universe, and everything. So, oh, I love this audience. You know, there's like sometimes there are audiences when I show that and I have no clue what I'm talking about. It's like dead silence. I love you guys. Makes me feel good. It's good. So this was our expedition poster, and of course, "Don't panic" was our motto. Don't panic, also in front of a pretty big workload. I mean, there was a lot of work up there to do, and I spent a lot of time in this module specifically. It looks a little bit like a soda can. The space station is made up of many of those modules. We call them pressurized modules. They have air inside, and we can float and breathe and live and work in there. And this one specifically is the Columbus. It's the science laboratory, which was provided by the European Space Agency. And I spent a lot of time floating in there like that. In the background is Columbus. Doing a lot of science research. So the ISS is a laboratory. Why do we have to go to space to do science? Because in space we have a thing called microgravity, which is a fancy word for weightlessness. And in weightlessness, there are things that happen that are interesting from a scientific point of view, both from the life sciences perspective. So we study the human body, we study cell cultures, tissue cultures, animal models, plants, to understand what happens to biological systems in weightlessness. How do they adapt? That actually makes us understand better how all those systems, including our bodies, actually work and function. But also from the physical point of view, a lot of disciplines in physical sciences are interested in doing research in microgravity. For example, combustion, fluid science, fluid mechanics, material science. Those are some of the typical fields. So for example, there what I have in my hand in those boxes are cultures of stem cells. And the scientists incubated them, or I incubated them for about 36 hours, I believe, to see whether weightlessness affects the way they differentiate in different types of cells. So we try to set aside as much time as possible up there for science. Of course, we also have to fix things. The ISS is a very complex machine. Now imagine your car, which is complex, but not quite as much. It still breaks down once in a while, or you just have to bring it in, unless you're able to do it yourself for periodic maintenance. So imagine that exploded a lot on a very big, very complex machine like the space station. So we did spend some time with the tools actually fixing things. The good news is we have an amazing toolbox. I think it's the dream. This is just a part of it. It's like a lot bigger than that. And I think that's the dream of any do-it-yourself geek. I thought it was cool. So anyway, this is just an example of some fixing. All those panels that you see, when you open them, then there is all this life in the back, a lot of hydraulics, a lot of pipes, a lot of electric conduits that keep the space station and us alive. Now, sometimes you get to do cool things like building things that are going to go out in outer space. For example, in this case, through this small airlock, which is in the Japanese laboratory GEM. So you mount things on the slide table, then you slide it in, close the hatch, recover as much as possible the air from the airlock itself, and then you open the door on the outer side, you slide the table out, and for example, this round satellite there is ready to be picked up by the Japanese robotic arm, and it can be put into a orbit. And we did that a lot for this tiny little satellites called CubeSats. They look a little bit like Borg ships. I don't know if you can see one there in front of the, tiny Borg ship in front of the solar panel. Those are relatively cheap and easy to do, so sometimes universities do them for their students, and we actually are able to deploy them into orbit with this simple system. Now, sometimes when you're up there for 200 days, it might be that you're fed up with your crewmates and you want to send them out for a walk. And that's what I did. No, just kidding. But I did support, this is where you train for spacewalks underwater. It's the only way we have found to simulate for many hours weightlessness. As you all know, we cannot turn off gravity. There is no such thing. So we have to cleverly figure out ways where we can simulate being able to work in the 3 dimensions in different orientations. So I did support 3 spacewalks of my crewmates, Butch and Terry. I was very sad I didn't get to go out myself on this mission, but very hopeful it will happen next time. The other cool thing I got to do is to be at the controls of the robotic arm of the space station, and you can see this robotic control station. And I did that in order to capture what we call a visiting vehicle, a cargo resupply vehicle, a little messenger from Earth with a few tons of vital supplies, not only for scientific research and experiments, and of course also for us as human beings to be able to survive up there. So these vehicles, Dragon and also Cygnus, which is another one, or HTV, which is again another one, they do not dock on their own to space station. They come, they find us, which is really cool in the big expanse of space. You know, I'm always fascinated by rendezvous because in this big vastness of, of nothing, of emptiness, they actually come and find the only place where, whoa, sorry, I just caught a glimpse of a person there, very unsettling. The costume, I mean, the person I'm sure is a wonderful person. Yeah, so they come and rendezvous with space station, and then they fly formation at about 10 meters distance, and then we go out with the robotic arm and capture them, and then they take control from the ground and berth them to the space station, and then all of a sudden we have an extra room and a lot of supplies to unload. Now this one had a very, very special supply for me, for us, but for me especially, which was the very first space espresso machine. Yes, very important. Very important. So now it's a little bit cumbersome because they did this, they were really great, this engineering team. They did it very quickly for ISS standards because, you know, it's very complex to design something for ISS. And what they did to be able to do it quickly is like, okay, let's forget about attaching it to the water supply of a space station. We'll make it independently. So you had this one pouch with the water you would put in, and then it would just like suck this water and pass it through the coffee capsule. You know, of course, high pressure, high temperature, very scary for the safety people of ISS. Pressure, temperature, not good. So that's why it's so bulky, because, you know, every conduit has like three safety valves, you know, triple redundancy and everything. And then the coffee comes out in this other pouch, which is great, but then you cannot smell it, right? Which is kind of like part of the pleasure of drinking coffee. So I was really happy when they actually sent me up zero gravity coffee cups. Because seriously, you don't think about it, but you know, the reason why we have these pouches to drink fluids, okay, of course you need to contain fluids, but if it was just for a short time, the fluids are not going anywhere unless you start shaking them. So you know, if you put them in a cup, they're gonna more or less stay there. The problem is that when you do like that, nothing happens. It doesn't come out. It doesn't come out. So this genius, a little bit crazy scientist, but totally brilliant astronaut at NASA, Don Pettit, he had this idea of creating those cups. You can't really see it there, but they have this drop shape, and then the angle is calculated in a way that the liquids actually want to come out, just per capillary action. So you just can put it on your lips, and they actually want to come out to your lips. So that's how we did it. So of course, this that you see is the cupola, which is every astronaut's favorite module, because it's your window on Earth, and you have this beautiful view on the planet, and you can see things like sunsets and sunrises. Potentially, if you wanted to stay at the window 24 hours, you could see 15 sunrises and 15 sunsets, just because we go around the world in about 90 minutes. You can see amazing things like auroras, and beautiful, beautiful views of the planet. Yeah, but eventually my 200 days were up. It was time to say goodbye and leave and get back in our tiny little spacecraft. After 200 days in this amazing, very big facility, which is the ISS, the Soyuz definitely felt very, very small. A very short ride home, but hey, quite a wild ride. Basically, coming back through the atmosphere at almost your entire speed, which is 20,000 kilometers per hour, and it's the atmosphere itself that breaks you down, that takes away all that speed. So basically, you're coming back in a fireball. There's literally like flames going outside of your window, and it's becoming darker and darker because the outside of the window is actually burning and becoming black. And then after that, the parachute opens. and you're just, relatively smoothly coming down, attached under the parachute for about 10 kilometers. And then at the very last fraction of a second, you can see there, just before impact, the retro rockets fire up, just to soften a little bit your landing. I hope with some irony, the Russians call it the soft landing engines. And you can see the soft landing on the right. Yes, they have some sense of humor. So that was the end of our mission. I'm just going to show you very few slides. I cannot go into detail of what's planned in the world at this time for the future of space exploration, but I will try to just give you a glimpse of it, because I don't like to only talk about what's been, but I also like to talk about what is coming. Of course, we continue to operate ISS. The International Space Station is going to continue its operations at least until 2024. Some people are already talking about extending it beyond. The next European mission on ISS is the mission Horizons of my colleague Alexander Gerst from Germany, so I'm sure many of you know him. And he will launch to ISS on the 6th of June for another mission similar to the one I talked to you about. And he's the first shenanigan, that's how we call ourselves, our class of 2009, going up there for his second mission. So hopefully he's going to be the first of us all getting a second chance to go to space. Some cool things happening to ISS in the next years. Well, there's a push to what we call commercialization, so offering platforms like on the market for entities out there that want to buy opportunities to do research in microgravity. One of them is Bartolomeo. So you can see this, again, this soda can there is still the Columbus I showed you before, and all these like boxes outside, well, 2 of them do exist now, but the rest will be this new external platform that will be built in the next years. One thing that was attached to ISS after I left very recently is a inflatable. So this is one of the other possible technologies that are being investigated. Instead of sending up a rigid soda can we send up something that will inflate when it's in space, so we can save volume and mass at launch, because this is really nowadays still the main cost driver of space missions, is how much it costs to launch things into space. Then there's private companies who are making plans. This is of course a drawing, doesn't exist, but plans for potentially maybe in the early 2020s actually placing in low Earth orbit privately built, launched, and operated platforms, again, for microgravity research, but certainly also for paying customers. So if you guys are saving some money, this might be an option. I'm sure it won't be expensive at all. I mean, they haven't published the prices, but I'm sure it won't be expensive. I'm sure. Then the Chinese are going to build, definitely, a space station. They've already, on the ground, some components have already been built. The first module will be launched if the plan is, according to the plan, in 2020. And by the early 2020s, they will want to be finished building at least this initial configuration with these 3 modules. We've actually started a cooperation with them as European Space Agency with the hope, I mean, nothing is certain for sure yet, but with the hope that maybe one day one or more European astronauts will have a chance to also fly on the Chinese space station. So this is me with 2 taikonauts, 2 Chinese colleagues, during a water survival training event in China last year. It was a big deal because it was the first time that a non-Chinese actually trained with the Chinese in China. Okay, then if we look beyond low Earth orbit, so towards the moon and Mars, actually have to go a little bit to the past to talk to you about the future in this case. I want to show you ATV, the Automated Transfer Vehicle. It's another one of those vehicles that used in the past to resupply space station. The last one flew when I was up there. I actually sent home the very last ATV, ATV-5, in February 2015. So we don't build them anymore because they're not needed anymore for a space station, but the technology of ATV, further developed of course, is flowing into this new project, which is called Orion. It's a spaceship that is going to allow astronauts to fly beyond low Earth orbit, so back towards the lunar orbit, and eventually enable also missions on the surface of the moon. This is not going to land on the moon, but it's going to be an enabling piece of the puzzle. And why I talked about ATV, because the technology of ATV is flowing into what we call the Orion service module. So all this cylindrical part on the back with the 4 solar panels, which has propulsion and power supply and thermal control. So a very, very important part. I mean, Orion couldn't obviously go anywhere without a service module. Is actually built here in Europe. And then, of course, there's going to be a rocket that will enable exploration beyond low Earth orbit. This is called SLS, Space Launch System. Has been in development in the US now for, well, probably almost a decade. And the maiden flight is expected next year, I believe. And then we would have basically Orion flying on top of it. And it would have then also some extra free upload capability, some more mass that we can fly along. And we would use that opportunity to actually fly the modules, the components of what used to be called the Deep Space Gateway for a while. I think now they've changed the name again, but don't worry about the name. But it's going to be a space station, not as fancy, not as big, not as complicated as the International Space Station, a lot smaller, at least initially. But it's going to be a lot further away. It's going to be in an orbit around the moon. And this Orion spaceship will fly astronauts there and back. Probably not continuously manned, not like space station. It will be more like astronauts will go there for a mission of maybe 30 days and then come back, and then maybe in the next year another similar mission, at least initially. And the orbit has been chosen so that once every 7 days it comes very close to the moon surface so that it can enable actual surface missions. Now the first surface missions will likely be robotic. And ESA is proposing, it's not been completely approved yet, but one of the things that is proposed is a robotic precursor mission, making use of the habitat, where you would have a lander landing on the surface of the moon, a rover doing a geology traverse, organized, developed, designed with the scientists so that we can maximize the science return, and actually go and pick up samples, put them on an ascender, an automatic ascender that would go back to Gateway so that the samples can be retrieved, and then the human crew on Gateway can bring them back to Earth on Orion. So this is one of the configuration that is proposed. For things like that, it will take a while. Won't quite happen immediately, but of course we do have the hope that in the next decade we will be able to have again boots on the surface of the moon. Now, of course, we don't have the kind of money that people used to have in the Apollo times. So we are being very, very careful nowadays when we propose missions, especially when we talk about moon surface, to make sure they are sustainable and robust from an economic point of view, so that the programs are not going to just be canceled eventually because they're too expensive or considered too expensive. So one of the options that's being proposed now, and I don't have a picture of that unfortunately, but is to have initial missions being supported by pressurized rovers. So you would have these rovers put on the surface of the moon, and they would be able to support 2 astronauts for a number of weeks, and then the astronauts would land, transfer to those rovers, and the rovers would serve as habitats, but they would be mobile, so you would actually be able to go around and explore in the rovers themselves. Now, for actual semi-permanent or semi-permanent infrastructures on the moon like that, as I said, that's certainly for further in the future, but we do have quite some robust technology development programs looking into that, especially when it comes to in situ resource utilization. Again, we want to make these missions doable, also affordable from an economic point of view. And one of the keys might be not having to bring everything from home, but actually being able to exploit some of the resources on the ground. It seems, if you look at the moon, it's covered in this regolith, and it looks pretty empty and arid. But actually, the regolith does contain resources. So one of the efforts for the next decade, for sure, is going to be to have robotic missions land, especially on the moon south pole, and characterize the resources in situ. So what is actually there in the regolith that can be exploited? There is a planned, already in the books, Russian mission, Lunar Resource 27, where actually as ESA we will provide technology, both for the automated landing and also for a drill that is going to drill in the ground to be able to better understand what is in there. And then, of course, in the future, there's actually already studies looking into how we could use this regolith to actually sinter, so produce, kind of compact it and make it structurally stable, so that you can use these bricks and with these bricks potentially build structures. So you wouldn't have to bring your construction material from home. You could use the regolith for radiation protection. You could use the regolith for thermal balance. So there's a lot of technology development going into that direction. Just please don't expect it to happen today or tomorrow. I mean, it's quite some early technology development for the moment. Okay, what about if we move from the whitish regolith of the moon to the reddish surface of Mars? And I'm just going to talk about the European Space Agency projects, endeavors for the moment, otherwise it would be a very wide discussion. Of course, you might know ExoMars. The orbiter, which is on the top left, is already in orbit, was launched about 2 years ago. It's the TGO, and is working successfully. We did have an attempt of a demonstrator mission landing on the surface, which was the lander Schiaparelli, which wasn't quite successful. That was definitely a hard landing. But of course, we hope to make it successfully next time. I mean, we did learn quite a lot from, let's call it, this failure or semi-failure of Schiaparelli. And of course, lots of lessons learned to be implemented in the next attempt when the actual rover will land on the surface of Mars in 2020. And the cool thing is that it also will have a drill. So for the first time, we will be able to penetrate quite deep, I think it's 1 meter, in the surface of Mars. Right now, we've only been able to look at the surface or to scratch the surface, to go down for a few centimeters. So that's definitely new. And then there's preliminary agreements for a Mars sample return mission. So I talked earlier about bringing samples back from the moon. That is cool, but it's already been done. I mean, we have, I think, about 400 kilograms of moon rocks that were brought back by Apollo astronauts. So this would be totally cool because it would be the first time that we actually bring back samples from the surface of Mars. So stay tuned. The mission is called Mars Sample Return, or at some point I'm sure it will get a cool name, but for now it's called Mars Sample Return. So stay cool, stay tuned for that. And of course, again, step by step, I think it's important to get excited about these important technology development steps and intermediate missions before we talk about actually bringing humans on the surface of the planet. And anyway, they have a tendency to get lost, and then it's terrible. All right, and I'm just gonna end with this slide. Just a reminder that when you get upset and angry at your fellow human beings, remember that we're all in there in this little, very, very tiny little dot in the sky. Thank you very much. Okay, I think we have about 20 minutes for questions, and I've been told there's going to be some fancy light that is going to shine on somebody, and then that somebody will be able to ask questions.
Yeah.
There we go.
Morning, Samantha. Nice to see you again. And my question is connected to the last picture you did show. As you trained with Matthias Maurer, with the Chinese astronauts, what are your hopes? Do you think it would be just a nice gesture to begin a cooperation? Or could you imagine being traveling with these guys to their space station?
Okay, I think the initial part of the question I couldn't quite hear, but I think you're talking about the Chinese cooperation.
Yeah,
right?
the Chinese cooperation, and you did the training with Matthias Maurer.
Yes.
Do you think it was just a nice gesture to begin this cooperation, or could you imagine yourself being a part of the mission to go to their space station?
Both statements are true. So it wasn't a nice gesture, but it was definitely a very beginning stage of a potential cooperation to maybe one day myself or another European astronaut flying to the Chinese space station. There's a memorandum of understanding between ESA and the Chinese space station that goes back to 2012 that high level states that goal. Now, of course, between that and actually implementing it and having a launch date for myself or one of us, there's a lot of work between that and then. But definitely, this was a hugely important step because, as I said, especially for the Chinese, I think it was an important step because it was the first time that they actually welcomed a foreign astronaut to train in China with their astronauts. I mean, for us, we're so used to international cooperation that doesn't seem like a big deal, but we have to see it also from their perspective. From their perspective, I think it was a huge step in the direction of international cooperation, so definitely not to be underestimated.
Thank you.
Sure.
Hello, it's great to have you here. What was your feelings when you looked at our planet Earth at the first time?
I think the first time is really, I guess you're just overwhelmed by a very beautiful sight that you've never seen. I mean, we see pictures and we see videos, so of course you kind of know what to expect.
From the ISS the first time?
Yeah, no, I understand.
Okay.
And so I guess the first feeling that you get is just this overwhelming beauty of this spectacle that is very unique. And then, of course, over time, I mean, when you're up there 200 days, in some ways you get used to it. In some ways, every day there's something that surprises you because it's new. I mean, the surface of the planet, we only see a tiny surface from a tiny piece of the planet from ISS because we're very close, about 400 kilometers. But then you keep going around and the orbit shifts every time. So basically you're covering all of the surface of the planet up to 51 degrees north and 51 degrees south. So there is always something new, something to discover, something related to the changing seasons, something related to weather phenomena, to auroras, to sunrises, to sunsets, to the different illumination scenarios. It's really a constant discovery. Up to 200, I mean, I think the day before I left, I saw something that I really, really wanted to see, which were noctilucent clouds. These are very, very high clouds up in the stratosphere, and they're very flimsy, they're very light, and the only way to see them, you don't see them in daylight. So the only way to see them is when the sun has just set and is basically illuminating them from beneath the horizon. And I really wanted to see them, and I literally saw them, I think, on day 198 or 199. So, I was still discovering things very late in the game.
Thank you.
Sure.
Hello, I'm Peter. I can't emphasize how glad I am that you are here and the whole ESA team. Thank you so much to bring science to FedCon. That is marvelous. Thank you. And of course, I have two questions. You're doing a lot of research. I'm always wondering, because I know you have cooperations with universities, you have cooperations with companies. How much percentage-wise, approximately, is your own research, your research you're doing for the universities and corporations, your research you're doing with the companies, maybe who hired a cubic for the ISS, and are you going to be mentioned on the papers?
Well, the first part, how much is my research, is very easy to answer, 0. Well, personally, I'm not even a scientist, so it wouldn't even be my job, but even astronauts who are scientists, that once they become astronauts, they give up that right of proposing their own experiments. We are just what we call operators. I mean, we are really paid. We're not paid to decide anything. We're not paid to make any choices. We're not paid to do any, management decisions. We're really only paid to do what we are told to do without doing any mistakes, possibly. I mean, we all do mistakes, but as little as possible. So that's a typical job of an operator, and this is really what we do. And also the scientists, astronauts, those are the ones who have a hardest time with this. You know, for us coming from the military is easier because that's what we do in the military as well. Yeah. But for scientists, astronaut is always a little bit of a shift in perspective that they have to accept. What the split is between university and industry, I'm not really sure. I think it's mostly university, and we're trying, especially in the US, they're a little bit ahead in that, into trying to involve also, let's say, more science with more immediate applications, so R&D from industrial entities, so it's becoming more and more. And I'm usually not cited in the papers. Sometimes if they think I did a really good job in actually performing their experiments, they will add me sometimes at the far end, not at the very end, that's an important author, but sometimes, I don't know, 9th or 10th author, and then specify if she did the experiment for us, and we're grateful.
Thank you so much.
Good morning. I have two little questions, and I was wondering, you're working together on the ISS with civilian background, military background. Can you elaborate a bit on the command structure? Who's in charge? How do you work together on the ISS? And the other question is, since you are obviously an insider, do you think there's a chance for a German woman going to space anytime soon? Thank you.
Okay, yeah, so the command structure, well, you don't have to imagine it like a Star Trek type or military type. I mean, it's a very loose command structure, let's say, on ISS. We have a commander, of course, we have a person designated as commander, and this person, he or she has mostly a coordinating role, so making sure that everything runs smoothly on board, helping and solving issues that just might come with living together, with deciding on board how we do things. But all important decisions affecting the actual work on the International Space Station, those are taken by the flight director and the very complicated international management structure of the ISS program. Now, if you run into an emergency when there is no time to call and ask for a meeting to take place somewhere on the ground and then let us know the answer, then of course then the commander has the responsibility of taking decisions that affect the safety of the crew. So I don't know, if there is a fire on board or a depressurization, you know, we're starting to lose atmosphere into space, and there is a real-time decision to be made, then the commander will make that decision. But more than that, the commander has a responsibility to make sure that we work together as a crew, also in an emergency situation. You know, we're 6 people, and sometimes it's easier to I don't know, run an emergency procedure with 3 people, because then, you know, you don't interfere with each other. So it's a big responsibility of the commander to make sure with a 6-person crew in an emergency, everybody knows exactly what to do so that we help each other and do not interfere with each other. But it's not a command structure. I mean, the commander, again, smoothing things out is what the commander typically does on board. And in terms of a German woman, well, we do not have at this time a German woman in the European Astronaut Corps. I believe that there is a private initiative which has been running for some time to privately select and privately fund potentially the training and the flight of a German woman. But I'm not aware of where they are in terms of implementation. I know they have selected 2 candidates, but I don't know where they are right now in terms of being able to implement this.
Hello. I'd like to ask, what's it like having to readapt to normal Earth gravity once you've been up in the ISS for so long?
It's terrible. So gravity is a mistake. I'm going to tell you that. Total mistake. No, I'm just kidding. No, it's harder though than adapting to being in space. Well, at least it was for me. Some people get sick when you get to space. So for maybe, I don't know, 1, 2, 3, 4 days, they actually have nausea and they have to take medicine. but then they adapt. And for me, I thought that going to space, I was instantly adapted. I felt well from the very beginning, and coming back was definitely tougher. I mean, your body is completely not used anymore to deal with gravity. Some of it is just in your brain. I mean, your brain needs to get used again to the proper perception of your weight. To actually fire the proper muscles to all the things that we learn as toddlers usually, right? I pick up a glass and I know how much strength I need to pick up the glass, or I need to, I don't know, raise myself from bed, and I know how much strength I need for that. All of that the brain needs to get used to, which it doesn't take long, maybe a day or two. But then also your muscles and your joints, even just sitting is painful because you're just not used to having the weight of your body on your rear side. I guess it's the same as when people lay down for a long time in bed because they've been sick or they had an accident. It's a little bit like that. And then your vestibular system is off. And again, it takes maybe a few days. They don't let you drive or ride bicycles until you pass the vibrating platform test, which I did. I did the first time after 2 or 3 or 4 days. I don't know. It was still quite off, although I felt fine. But the platform said, no. You don't drive. And then after 10 days after landing, I did it the second time. And then I was back to pre-flight, or even better in some cases. So somewhere between 4 and 10 days, then the vestibular system was back to normal.
Okay, thank you.
Yeah, sure.
Hello. First of all, thank you for this presentation. It was really good. Always nice to see people presenting real science with a little bit of humor. And then I also have 2 questions. The first one is, are you available for autographs at any point? And will that be at the ESA stand, or will this be here next to the stage or wherever? Because I would really like you to sign this. And the second one is, there's a record for how long a woman has been in space. Do you think it's a good thing that women and men are treated differently in space flight expeditions? And did you feel that you were treated any different because you were a woman?
Not the autographs. I don't know. I don't think it's planned. I don't know if we do some kind of real-time combat planning, it might happen, but I'm not sure. As for being treated differently, that doesn't really happen, to be treated differently in the actual work. In training and assignments and actual work you perform on space station. It's actually pretty gender neutral. I mean, I never had the perception that it affected in any way my work. Of course, it affects everything which is outside perception, everything which is media work, everything which is public communication work, everything which is records. That's where it makes a difference. But it's really not the core of my job. So I mean, I take it with, I don't lose sleep over it. I mean, I guess it's okay. I guess it's also normal, when you're a smaller number, that you attract more attention, especially maybe women out there. They pay more attention to female astronauts. I did when I was growing up. I certainly knew more about, the biographies of female astronauts than I did about men. Is it right? Is it wrong? Is it a product of a time where women have been and maybe continue to be a minority? That may be. I mean, I think it has pros and cons. And again, it really does not affect my actual work as an astronaut.
Thank you.
You're welcome.
Buongiorno. I wanted to ask for your opinion regarding the efforts of SpaceX by Elon Musk regarding using reusable rockets. I saw the first test of the Space Heavy rocket, and when they succeeded to land simultaneously both rocket outer boosters, and from the engineering point of view, I find it quite awesome, and I wanted to want to ask you what your opinion is regarding these efforts and if they are able to reach Mars or the moon and make it cheaper in the future.
I think so. I mean, I was just as excited as you probably were when I saw that image of the boosters re-landing. I mean, that really looked like a science fiction movie, but it was real. Yeah, I mean, it's. I think private companies like SpaceX, maybe especially SpaceX, I think maybe they have shown that they're very capable of leveraging technology developments in other fields quite quickly. And maybe in that sense they have an advantage with respect to legacy companies or public agencies. Just a few years ago, a lot of people thought that landing boosters was impossible. Now, of course, intelligent adaptive algorithms that have been, have become a lot more powerful and performing in the last few years have enabled that, so that the boosters can actually compute their trajectory real time, reacting to atmospheric influences that you cannot just plan ahead of time. So that of course is interesting. So I think there's a lot of potential there to try and dare new applications and the application of technologies that come from outside of the space business. Again, with a little bit more or shorter reaction time than legacy agents. And then, yeah, bring us to the moon or Mars. I think that SpaceX has shown to be a very successful company when it comes to launchers, to rockets, and that's wonderful, and I think that will certainly contribute to enabling what I said earlier, so sustainable moon exploration. I think the Falcon 9 Heavy will certainly be part of the launch architecture of this new moon program that will start in the next decade. For sure there will be missions where it is more adapted than the huge space launch system. I have no doubt about that. Now, of course, when we're talking about moon missions and Mars missions, the launcher is an important part, but it's only one part. So where I'm a little bit more skeptical is when we're talking about those missions and very ambitious plans that are presented, but of course with very few details. But I think they're also very honest. I mean, they always say, we're a rocket company, we provide transportation, everything else somebody else has to take care of. Well, that everything else is quite complicated, especially when we're talking about landing on Mars. I mean, we have landed on Mars, the biggest we have landed on Mars, we being NASA, is 1 ton, I believe, Curiosity. And we are going to have to increase that by at least an order of magnitude if we want to have an actual human mission. And nobody quite knows how to do that for now. But again, there's so many exciting technological developments in the fields of computational tools, artificial intelligence. All of that might really enable in a nearer future than we think, things that maybe a few years ago sounded impossible.
Thank you very much.
Good morning. Thank you very much for your great presentation. I have perhaps a funny question. When you was on the space station, I read an interview with you in the German newspaper, Süddeutsche Zeitung, and they ask you about the movie Gravity, and you start laughing. Perhaps it's the same if you ask a boxer about the Rocky movies. It's probably the same. Can you tell us how close is this movie, what the movie shows to the reality, and what happened in this movie? Of course, we hope it will be never happened. How the people work on to save the space station and the people there working in there? Because we all know there's a lot of particles around the Earth, and it is perhaps really dangerous.
Yes. So, and I'm really sorry, I should have said this before. I think this was the last question because it showed me only 2 minutes left. I'm sorry I didn't give you a warning. So gravity, yeah. Well, I laugh just because, of course, almost everything that happens in the movie is not really plausible, but really almost everything. So, including the underwear of, what's her name, of Sandra Bullock. That said, the way they reconstructed space station is extremely realistic. So if you want to have a feeling of the interior of the space station or flying through space station, I think the movie is great in that sense. I mean, they did an amazing job of recreating in the movie the environment. So a catastrophic debris event like we see on Gravity, I would say is pretty much impossible or extremely unlikely. But yes, we do prepare for what we call a rapid depressurization scenario. The reason being that, as you rightly say, there is a lot of debris up there. And when we're talking about debris which is bigger than 10 centimeters, then usually those pieces of debris are tracked. We have radars on the ground that are able to watch them. And the space station manager's program is very, very careful. So we have one big pizza box around the space station, several kilometers, I think 25 kilometers wide. And if there is a very tiny chance, tiny being, I believe 1 in 10,000 or more, that a piece of debris bigger than 10 centimeters, so what we can see, is going to fly through that pizza box, we move the space station. We get out of the way. Especially in the past, it used to happen, we don't get an early enough warning, so we are told too late and the space station cannot be moved, then the crew shelters in place. So they close all the hatches of space station to make sure that if there is a hole, it is contained to one module and it does not affect the air of the entire space station. And then they go to their Soyuz, ready to evacuate just in case. So we are very, very conservative on possible collisions with space debris. Space debris which is smaller, like 1 centimeter or smaller, is usually caught by the micro meteorite protection shielding outside space station. So there is a first layer that kind of like vaporizes them so that by the time they actually hit the hull, they are like in tiny pieces so the pressure is distributed and they do not go through. Now there is this, you probably noticed that between 10 centimeters and 1 centimeters, there is a lot of centimeters. So those, we cannot see them, and we are not quite sure that they would be halted by the micrometeorite shield. That is why we train for a rapid depressurization scenario. So if you had one go through, then of course the pressure on space station would start to drop, you would have all alarms go off, or you would feel it in your ears, or Houston would call you and tell you, hey, something's going on. Something would happen and you would notice it. And then you either immediately understand where it is, it can happen, and then you need to close that module, and make sure you're on the right side, not the wrong side. Or then you have to go and look for it. If it's like a tiny hole and you have a relatively slow progression, then you might not quite understand where it is, especially if it's behind the rack. So then you go systematically through space station and you seal off one module at a time until the leak stops, until the pressure stabilizes. And then you know that it's somewhere on the other side. And then you have some leak repair kits that you might try to use, but at that time, once you've isolated the leak, then you would start talking to the ground and discussing what you might try to do to save. Now, if you have a big hole and the pressure is going down very quickly, then you have to leave station, because then you don't have the time to go and look for the hole. Yeah, so I have a panel is over message here, so I'm really sorry.
Ladies and gentlemen, Samantha Christoforetti.
Thank you.
Thank you.
Vielen Dank, dass ihr euch das Video angesehen habt. Wenn es euch gefallen hat, dann lasst einen Daumen nach oben da. Hier habt ihr nun verschiedene Auswahlmöglichkeiten. Ihr könnt oben links unseren Kanal abonnieren. Oben rechts geht es weiter zu tollen Videos von diesem Event. Unten rechts gelangt ihr zur Internetseite vom nächsten Event. Zu guter Letzt kann ich euch noch den Space Store empfehlen. Hier gibt es alles Mögliche an Fanartikeln zu euren Lieblingsserien und Filmen. Bis demnächst auf diesem Kanal.